Welcome back. I'm Aurys, and this is simulating i16. Up here we have the information window. It tells you what happens anytime you press a button. This here is a scripting environment. You can write your own scripts or import some of the examples. Here we have a fairly standard dB calculation. To view the outputs, we need to open up the system console, and it runs. It does a scan along the way, and when it finishes, it updates the diffractometer to match the calculation. Then down here we have the console. After importing the commands, we can control the diffractometer using the same commands as we would in real life. Then in the user interface, we have an option to import files. So let's do that. In the download, we have a few options. For example, an old experiment with copper cobalt 3. Press import. It imports and updates the state to what it was back in the day. Now we have the option to check for collisions. First, let's disable safety limits so it's easier to cause one. And now if we check, it tells us what collided and highlights the things that collided. Let's turn the safety limits back on. Now we have an option to move in HKL space. We can also switch between horizontal and vertical modes of operation. And back. There's an option for inverse kinematics that lets us control the rotation by directly setting rotations in the lap frame. And there's the beamline cameras as well. We can view as we would from one of the webcams, or the sample camera. Doesn't look like much. Let's disable our reciprocal lattice vectors and axis of rotation, go to a fairly standard position, and we're seeing the sample holder from the side. Looks much nicer if we view it as the pin. Now the thing I was fiddling with was the outliner. It lets you choose which objects you want to show or hide in the simulation. And if you click on anything, it highlights in the outliner so you can read off what it is. For example, this vector I just clicked on is the B star reciprocal lattice vector. Then we can also show some of the axes of rotation, for example, kappa, and hide diffractometer arms. When we check for collisions, it only checks meshes which are visible, so hiding them makes the simulation run faster. And we can also change between sample environments. For example, put a dome on the cryostat. And if we want to be more adventurous, we can attach the pipe to it, which would normally supply liquid nitrogen. And if, for example, we knew that our experiment needs a few Tesla of magnetic field, we can also add the big magnet. Now, how much reciprocal space we can scan with the magnet in place is something I will let you determine. And well, thanks for watching, and good luck with your simulations.